Hello and welcome into the content video for lesson 12 for Precalculus 2. In lesson 12, we're going to be discussing solving trig equations. This is always a fascinating lesson from my side of the desk. Um, I will be honest with you, it is usually this section that most students struggle with, like on the final exam. So on the final exam, the trig equation question, very few students will get it right. On the midterm exams, very few students will get them right. And I've been teaching 127 now for about 12, 13 years. And no matter what I try, all the different variations and even other instructors just can't seem to make that connection. And what's the most confusing for me, or as an instructor, is that solving trig equations are no different than solving linear or quadratic equations. The only difference is that now you have trig functions in the equation as opposed to an x. So let me share my document camera here. So goes down there. Okay. So when we're talking about a trig equation, it's something that might look like 2 cosine of theta is equal to 1. And we need to solve for theta. And again, now that there's a cosine of theta here, it's like everything you guys ever learned about solving equations is gone. Like that's it. Like I don't know what to do from here because now there's a cosine in the problem. But it's you can think of it as 2x equals 1. So if I had, I guarantee every single one of you watching this video can tell me, oh, okay, we'll just divide by 2, so x is equal to a half. And that's true. The same thing holds true here. We eventually want to get to theta equals something because that's what we're trying to solve. So we divide by 2. So I get cosine of theta is a positive half. And now at this point, we then ask ourselves the question, and this is the question we're going to ask every time we get to the end of these trig equations, is where on the entire unit circle, so not just top half, right half, we're not doing that anymore, the entire unit circle is cosine equal to positive half. And so that's what? That's pi over 3 and 5 pi over 3, right? So that's all we're really going to be doing. And so in terms of the content, there's not really a lot of content because you guys either know your algebra or you don't at this point. And so I'll just give you some tips and hints how to try to solve these. And then again, in the example videos, we'll look at some actual examples. So first is solve exactly like a linear or quadratic equation, if that's the form that it has. Quadratic. So this example up here kind of has the form of a linear equation, right? It's just divide by 2 and then solve from there. And if you think of it, if we replace that cosine with an x, then it is a linear equation. And so that's what I would say then too. So if necessary, if these just completely mess with your head, and you're like, man, once I see that sine or cosine or tangent or whatever, I have no idea what to do. I just get stumped. So if necessary, change the trig function to an x and then solve for x and then put the trig function back. So again, if we look at this example up here, okay, 2 cosine of theta, I'm going to say x is equal to cosine of theta. So now I have 2x equals 1. Well, now I know divide everything by 2, so x equals half. But x is not what we started with. We started with what? Cosine of theta. So put that back in, and now we're at the point where is cosine of theta equal to half on the entire unit circle? The other thing that we're going to be doing on the majority of these is we're either going to factor and use the zero property rule, or if you want, if it's a quadratic, if I have like cosine squared and I change it out to an x squared, use the quadratic formula. So those are a couple ways that you guys are familiar with, and it's going to work with these problems as well. The thing, though, is to factor or to use the quadratic formula, we have to have the same variable, right? X's, or all y's, or all cosine, or all sine. So what we're going to want to do is substitute with the Holy Grail. So our main trig identity, Pythagorean identity, and or our double angle formulas. So a lot of these problems we'll be using, we'll be able to get all sines or all cosines by substituting the Holy Grail or the double angle formulas. And then again, once we do that and we get to sort of this final step, we have to ask ourselves the question. And I know when I gave you guys the inverse problems, I gave you the question to ask, where on the top half of the circle is cosine equal to a half? And none of you seem to bother to write it down, because every time we're in class and I'm like, okay, what question do you ask here? You look at me like I'm speaking a foreign language. So write this question down. This will help you. This is how you get your final answers. When you get to the point where you're at, like cosine of theta is a half, to finish solving these problems, you're going to ask where on the entire unit circle, so not just the top half or right half, is whatever trig function we have equal to whatever value we're given in the problem. So again, if we go back to this, so equal to the value question mark. So if we go back up to here, where on the entire unit circle is cosine equal to positive half? That gives us what? Theta is pi over 3, and theta is 5 pi over 3. And so the very last thing with these types of problems is you're going to be asked to state your answer in one of two ways. Either all solutions, because let's face it, up here, cosine of theta is a half at pi over 3 and 5 pi over 3, but it's also what? If I add 2 pi to this, and if I add 2 pi to that, and I add 4 pi and 4 pi and 6 pi and 6 pi. So I can keep adding values of 2 pi and keep ending up on the unit circle where the value of cosine is equal to half. So to notate that, if this says find all the solutions, you're going to write whatever the value is. So for example, theta is pi over 3, and then you're going to put plus 2 times pi times k. So for example, if I had theta is equal to pi over 3 plus 2 pi k. So when k is 0, this is gone. My answer is pi over 3. When k is 1, it's pi over 3 plus 2 pi. When k is 2, pi over 3 plus 4 pi, etc., etc., etc. And so this is for cosine, sine, secant, and cosecant. And it's plus pi k if we have tangent or cotangent. So depending what trig function we are using in the equation, That determines if it's pi k or 2 pi k. And then if it just says on the interval 0 to 2 pi, well, then this is just the unit circle values. So for our example up above, pi over 3, 5 pi over 3. So that's it. That's a lot of the tips that I can give you guys. Come on back. We'll work a bunch of examples. And really, these things get easier the more examples that you can work. So I know the mastery set only makes you do like 2 out of 3 or 3 out of 4 or whatever. I would try and work them all. See if you can answer all of them, because the more of them to do you can do, the more they all start to look the same, the easier they are going to get uh, to solve, be able to solve. So that's it. Come on back and we will look at our examples.